Hello, my maths people out there. It's October 21st, 9 p.m. in the evening at Nepal, and my early season of college applications are due 9 days. And just to get relaxed from those things, I'm doing this video of Laplace transform for an absolutely gorgeous integral. So we have this integral from negative infinity to infinity cos x over x squared plus 1 dx. Basically, for this integral, we are going to introduce another variable, and let's say a, and we will denote this integral I of a, and we will perform a Laplace transform in the world of a, and that will somehow simplify the integral, and we will deal with it. So let's go. So first of all, we can say the integral I of a, or define it in the following way. I of a equals to integral from minus infinity to infinity cos of ax by x squared plus 1 dx. Next, we will perform a Laplace transform in the world of a. Yeah. So if we perform a Laplace transform in the world of a will be dealt as variable. We will deal a as variable and x will be constant. And since these limits are also in the world of x, this will not matter us. Yeah, and the 1 by x squared plus 1 will also be a constant for us. And we need to take Laplace transform for this cos ax. And we know if we have cos of bm, and if we and here m is the variable of Laplace transform, and if b is the constant, Laplace transform will be s by s square plus b square, where s is a complex variable in the complex world after the transform. Yeah. So here we will have s by s square plus x square, since x was the constant and a was the variable of Laplace transform, and over here we have dx. So after this we can perform some partial fractions, and we can break this integral into partial parts. So basically we can use a cover up rule over here, and but before that let us take this s variable outside as a constant, and then now if we use cover up rule, the first denominator will be x squared plus 1, and to get its coefficient we just need to substitute minus 1 in place of x squared. So we will get 1 over this, in place of x square we will substitute minus 1. Yeah, and plus over here in place of x square we will substitute minus s square. So minus s square over here and plus 1 and dx. Now we have the partial fractions, and then Laplace transform of I of a is s times, and then now we can also take out this thing common, s square minus 1 denominator. Integral is from minus infinity to infinity 1 by x square plus 1 minus 1 by s square plus x square. So now we have progressed a lot, and now this integral seems a bit easier to deal with, and that's the benefit of taking Laplace transform. So we have Laplace transform of I of a as s by s square minus 1, and this will be tan inverse x minus 1 by s tan inverse x by s. So these are some pretty high school stuffs that you Definitely no, I guess. And now if we evaluate these at the limits that we require, we have Laplace transform of I of a as s by s square minus 1, and then this will be pi by 2 minus pi by 2s, and then at negative infinity, I guess we are stuck at this point. So basically, if we have to do it negative infinity, this will be negative pi by 2, so that should be plus pi by 2. Yeah, and then this will also be negative pi by 2. This one makes plus pi by 2. And again, our original minus sign will make it negative pi by 2s. Yeah. So this is it. I guess you have understood. Yeah. And now, what's going on? It's not under my control. Oh, how is it? What's going on? It's not under my control. I can't actually like. Okay, okay, but it's not working. I don't know why it is. Why it is that it's not working? Huh? Where did I go wrong? Okay, it's fine now. It's fine now. It's fine now. Yeah, and now the Laplace transform of I of a is s by s square minus 1, and then over here it's pi minus pi by s, which is s by s square minus 1 and pi taken out common, and then s minus 1 over s. Now we can have some pretty good cancellations, and we get Laplace transform of I of a to be equals to pi by s plus 1. Okay, so now we'll take inverse Laplace transform, and then with inverse Laplace transform, the s plus 1 will be e to the power minus a. Yeah, since a is our variable we are dealing with, and if it was t, then it would have been e to the power minus 1t, and this 1 is from over here. And now our original integral can is the integral when a equals to 1. Yeah, so with that in mind, we can just substitute a as 1, and we get I of 1 equals to pi to the power minus 1, so that's pi by e. What a beautiful result to get, pi by e. Two irrational and most famous constants in maths are related by this integral, solved by Laplace transform in the most beautiful way, in the most gorgeous way. So thanks for watching, hope you enjoyed the integral, and look forward to seeing you again soon in the next video.